We're going to talk about ideal gas laws in lesson 57. The ideal gas law equation is simply this, and you might have learned this in chemistry or something, but P1 times V1 over T1. P stands for pressure, V stands for volume, and T is temperature, as you would possibly expect. And that equals P2 V2 over T2. These are really easy word problems, all right? So in 57.1, I'll show you how to do these. 4 liters of an ideal gas at a temperature of 800 kelvins had a pressure of 100 newtons per square meter. If the volume was increased to 10 liters and the temperature reduced to 600 kelvins, what would the pressure be? Okay, let's figure out what we can make of all this. Well, let's find some clue words here. 4 liters. Well, when I see liters, well, let's look back at our equation. P1 V1 over T1 equals P2 V2 over T2. Well, does liters sound like pressure? No. Does it sound like temperature? No. But it does sound like volume. You drink, a liter of Dr. Pepper, whatever it is. So 4 liters, that would be our volume 1. It's the first volume we see, so we're going to plug that into our volume 1. So I'm going to plug that in right here. Of an ideal gas at a temperature of 800 kelvins. That one just told us. It said temperature of 800 kelvins. So we can plug that in for T1. And it had a pressure, it's being easy, it's pressure of 100 newtons per meter squared. Taking it easy on us. Now you don't have to put the measurement, you just put the number. Just remember the measurement for later. So we plug in 100 for the pressure. So now we have P1, V1, and T1. Now let's see if we have P2, V2, and T2. It says if the volume were increased to 10 liters, so volume to 10 liters, take out the V2 and put the 10, is increased, and the temperature reduced to 600 kelvins, temperature is 600 now, what would the pressure be? And then you just do the math. 100 times 4 is 400. That over 800 would reduce to 1/2. So that's nice. So we could say 1 over 2 equals P2 times 10 over 600. You could reduce a 0 here and there, so that would eliminate that, and then you'd be left with this to cross multiply. 60 equals P2 times 2. Divide by 2 to get P2 by itself. So the pressure equals 30, and then our measurement for pressure was newtons per meter squared. And that would be how you do ideal gas laws. Let's look at one more example. Throws in a little bit different lingo here. It says the temperature of a quantity of an ideal gas was held constant. Okay, so that's new. We'll get to that in a second. The original pressure was 7 atmospheres. Temperature, pressure was 7 atmospheres. Original volume was 42 liters. If volume was reduced 10, what was the final pressure? Okay, let's look at this one. Here's our formula, P1 V1 over T2, P2 V2 over T2. All right, let's see what it gives us. Well, let's look at this first sentence. It says the temperatures of the quantity ideal gas, so we're about to know something about the temperatures. Got our clue word. It said it was held constant. Okay, temperature was held constant. What does that mean? That means they're the same. If they're the same, we can just eliminate the temperature. Sorry. we can eliminate the temperature and be left with P2, P1, golly, I'm just messing everything up. P1 V1 equals P2 V2. We just crossed out the T1 and T2 in our equation. Now let's move on and see what we can find here. The original pressure, so that's P1, was 7 atmospheres. Original volume is 42. If the volume was reduced to 10, all right, volume reduced to 10, what was the final pressure? So, we do 7 times 42, 294 equals 10 P2, divide by 10, yeah, that's right. And we would get 29.4 for our pressure. And our pressure amount was atmospheres. And that can be abbreviated ATM. That's how you do ideal gas laws. Easy as that.